Hello, everyone. I hope that you guys are doing great. So this video is a midterm 1 review, and I'm going to go ahead and share my screen here via iPad. You should be able to see it soon. So this is a midterm 1 review. Again, midterm 1 consists of only chapter 2, sections 2.1 and 2.4. So the first question that I have listed is, suppose that you have two sets, the set A, which has elements I, J, K, L, and M, and G is a set that contains only two elements, A and J. The first question is a true or false question, and it says, is G not a subset of A? So I have a few notes for you. The first note is that this is a subset. This symbol is a subset or a set that contains all of the elements. That means that G must contain all the elements in A. So G only has 2 and A has more than 2. But we notice if we compare, A is not contained in the set A. Therefore, what we know is that this is true. The answer would be true. Why would it be true? The statement is true because not every element of the set G is contained in A. Okay. And so that would be the first question. Again, these are not going to be in order. I'm just going over some examples that you might have or some questions. This is a review, so they should be looking very similar to what you should be expecting on your test on your end. So I'm just trying to help you the most that I can. Okay, so make sure you're taking notes. Again, this is recorded, so if you guys would like to pause, by all means. So question 2, again, I am not going in order. Let's say we have a different example. Example 2, say let U, remember that U represents the universe. I'm going to say A, B, C, D, E, F, and G. And let's say that the set A contains A, B, C, and D. And then B contains the set, let's say A, B, C. Let's say we have this example. What we want to do is we want to find the intersection between A and B. So what we're looking for is we have a universe. Okay, so the universe contains all of the sets. So we have a universe, but we're comparing the set A and the set B. This symbol, this means intersection or what they have in common. What elements do they have in common? They can be numbers, variables, letters. Remember, anything inside are called elements. So intersection, this symbol means intersection. What elements do they share? That's what I'm looking for here. So the intersection between A and B, well, they share A and they share B and they share C. So your answer should be A, comma, B, comma, C. They don't share D because, well, first of all, the set A is bigger than the set B. Any questions? Okay, I hope that you guys are following along. All right, so let's see if we have a different example. Question number 3. Section number 3 is the following. Let the universe be 1, 2, 3, 4, 5, and 6. And we want to find the complement. of the set. Well, what does it mean to be the complement? The complement is very simple. It's what is not contained in the set. So in the set, we could say, oh, 7, 8, but the universe is finite, meaning it only has a certain. So what we have to know is apply the fact that the complement of a universe, a universal set, U, is always the empty set. And how does the empty set look like? It looks like this. So your answer would be the empty set. Okay. The empty set is always a complement of a universe, always, 100%, 100%. Okay. So your answer would be the empty set. Okay, question 4. Again, this is a review. So now we want to recall something very important. The formula. This is something that you need to know for your test. Of cardinality. Well, which one is that one? Well, there's a formula. The cardinality of the union between sets is n of A plus n of B minus the intersection of A intersect B. So this formula you have to know for the test. That will show up. So you might get a true or false question that regards this formula. So please make sure you have this formula down. Okay. This statement is very significant. So that is one of the sets, one of the questions. Now, using this knowledge, I'm going to ask a question. Question 5. So I want to find the value of the cardinality of A given the cardinality of B is 42. The union N of A, intersect B is 18. And the cardinality of the union is 60. I need to find the cardinality of A. So it's like we're solving an equation. So we already know we're going to use, so step 1, we're going to use the formula that we have, N of A or B is equal to N of A plus N of B minus N of A intersect B. And we're going to plug in what we know. So at this point, we have the N of A or B is 60 is equal to N of A. We don't know. This is unknown for us. We need to solve for this. Plus N of B is 42 minus 18. Okay. So the first thing we need to do is make sure that we isolate the variable N of A because that's what we're trying to solve. So we have 42 minus 18. We get 24. We have N of A plus 24 because that's what we get when we combine 42 and 18. Remember, you are allowed to use your calculator. And then we have 60 over here. Well, we subtract both sides by 24. and we get 36 is equal to the cardinality of A. Because again, 60 minus, we subtract both sides of the equation, we get 36. So our final answer should be 36 because we're solving for n of A. Maybe I will ask you to solve for n of B. So I can ask you to solve for which one. So all you're doing is solving for a general equation. Okay. All right, let's do a different question. Let's do question 6. So let's suppose that we have 6 different people and we want a set of 3 people, okay? So on here, let's say that we have, so John, Karina, Ellen, okay? Let me see, 1, 2, 3, 4, 5, 6. So let's say we have 5 people. So John, Karina, Ellen, Juan, and Marcos. Let's say we have these people and we are going to denote, I have 2 J's, I'm just change one for Lucy. And I'm going to denote them by J, K, E, L, and M. And what we want to do is find all of the possible sets. Find possible sets of 3. Okay. So for that, you're going to create subsets of 3 using 1, 2, 3, 4, 5 different letters. So I'm going to do a few examples. So I can either do J, K, and E. I could do J, K, and L. I could do J, K, and M. Okay. Then I could do K, E, L, K, E, M. And then I move on to E, L, M. And then, okay, so I could do the J, K, E, J, K, L, J, K, M, so on and so forth. I could do a variety with each one. And then, of course, well, you have to be very careful. You can do a variety of different ones. So the last one you can have is this ELM for the last set. So if you have JKE, of course, you can have a mixture of them. And then you can have JEL, JLM. You can have, and then the next one, KLM. And then there it is, okay? So you have to count which ones. So you can match the first J with 1, 2, 3, then the first J with ELM, so on and so forth. So you're doing a combination of these sets. So that's the way that you should be attempting this problem. Okay. All right, moving on. Let us move on to question 7. So question 7 is, let's say determine if we have a set or a subset. Okay, so if we have, let's say I give you K, L, M, and then I give you K, L, M, N. Well, what is this? Is this a set or a subset or both? Well, remember a set, let's say, contains all the elements. And a subset is a smaller set that contains all the elements. So first of all, K, K, L, L, M, M. Okay, this is a subset. And all of these are in here. So this is also a subset. So the answer is it's a set and a subset. They're both. It's a proper subset and it's a set. It's both. Okay? Because it's contained within each other. That's what this means. All right, let's go ahead and talk about a different example. Okay. Let's say we have question 8, that we have a universe. Let's say that the universe is 1, 2, 3, 5, 6, and 7. Okay. Let's say A is the set 1, 3. Let's say B is 3, 5. And then let's say C is the set 3, 4, 5. Oops, 3, 4, 5. My pencil is not cooperating with me. 3, 4, 5. And then last one. And then let's say D is 1, it's 2, 3, 4, 5, and 6. Okay. And we have a diagram where outside is, of course, our universe that contains the elements 1 through 7. We have on the inside C, this outside one, this big one is C, and then in the inside is B. We want to see if this is true. Well, what does this mean? That means that elements in B should be contained in C. Is that true? Well, 3, 5, 3, 5, yes. C is bigger because it has one more element. And are all of them inside? So 3, 4, 5, is that inside my universe? Yes, so this is true. The diagram is true. So all you're doing is analyzing the elements that correspond to your universe and satisfies with the diagram. Okay. All right, now let's talk about a Venn diagram. You should be familiar with Venn diagrams by now. You should have seen them. There are. So it says use a Venn diagram if I have, let's say, A and B intersect. So first you have the set A and the set B. I'm going to color it in first and then I'm going to erase it. So what do we know about the A and B? Sorry. A and B, I'm going to use the color red. That's so this A or B is actually A or B. Intersect B. So the intersection would be this. So where they match is actually only their intersection. So your final answer should only be this part. Okay. And B. Because you have all of A, all of A, all of B, and then intersect with B. So you're intersecting with B here. So they're actually matching in this direction. Okay. For every shaded area, we have to shade. This is about shading and knowing how to shade and how to mix the colors. Okay. So that was question 9. Question 10. Question 10, let's see. Okay, so you're describing here. So if I give you the set B minus A or C, how would I describe the symbols? Well, this means the set of all elements in B, but not in A, or in C. Okay, so this is this subtraction means not, this means or. All you're just doing is describing this in words. Nicely done. Okay, so now we have Cartesian product, question 11. So how do I do a Cartesian product? What does that mean? So if I have different sets, so let set A or let set B have A, B, C, and let's say G has the set L, M, N. And what you're trying to do is an order pair. So remember, B times G is not the same as B times G. So sorry, B times G, we're doing a cross product of each element with each other. It should be paired. So A, L, that's the first. A, M, that's the second. A, N, okay. Then we have B, L, B, M, B, N. Then we have CL, the order matters, CL, CM, and CN. That is the answer. And you have to put them in, I'm sorry, in pairs. So this looks like this. We should all have their coordinates. So this should look like this. And the commas matter, please. So this is CN. And this, all this is a set. Now, what if I say G times B? Well, now you're going the other way. You're going LA, LB, LC, and then you're doing MA, MB, MC, and then NA, NB, and then and all of this would be your second step. So you're going the opposite direction. This is called the Cartesian product. You should have 9 different ones. Okay. So the next thing you want to do is, so I hope that you guys don't have any questions there. Again, I'm only going to be doing a few. I'm not going to do the whole thing for you, but I'm trying to help you the most that I can. Remember, you are allowed to use your course notes for this. So I'm going over some of the highlights. Question 12. Finding the cardinality of a set. So find n of b, where b is the set of integers between -5 and 5. So if you have -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5. So the number between them would be 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 elements. That would be the number of sets. Because it's between, you're not counting -5 or 5. Okay, so we're going to go for that. Now, we want to know whether something is true or false about any, so we need to define, or you have to understand, what does it mean? What is an integer? What is a natural number? What is a whole number? And what is a rational and an irrational? And then a real number. Okay. Well, integers contain positive, negatives, we have integers contain 0 and negative numbers. And so -3, -4, dot, 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 3, 4. You have a few. A natural number is different. So when you're dealing with a natural number, you have to note that natural numbers are 1, 2, 3, 4. These are your counting numbers. Your whole numbers include 0. That's the difference. Your rationals are integer over an integer. So it can look like a fraction. So 1 can be an integer, 2 can be an integer because they can be all over 1. -1 can be an integer, 1/2 is rational, 1/3, and any fraction type. Irrational would be something like pi, the square root of 2, the square root of 3. And a real number is everything, no restrictions. So if I ask you whether something is true or false, and I'll say, let's say this is -1, 2, 3 are sets of integers. Well, is that true or is that false? Well, integers contain 0 and negatives. Yep, that's true. So it is a set. Yes or no? Okay. Again, you're going to have a few questions that require you to use the formula of cardinality. So you're going to be using this quite often. So make sure you know how to do something like this. I'm going to ask you to do this a few times on your test. Okay, and then let's go over a different question. Let's do question 14. Again, I'm skipping and I'm doing some of the questions. I'm not going to do all of them, but definitely this is a practice where you guys can see what type of flavor of questions you should be expecting on your midterm. And of course, you are going to be allowed to use your notes. Okay. So use the sets to find so let's say I have F or D intersect with E. And let's say that I give you the set D to be A, B, and C. And let me say that E is A, D, and the K, and F, B, B, C, D, K, L, M. Let's say we have this. So we want to find this. Well, the first thing we want to do is actually, what is the intersection between the sets D and D? Well, the intersection between D and E are A, and that's it. That's all they match. So then I have F or A. So F or A is A and everything else. So F or A will be A, B, C, D, K, L, and M. Because it's the conjunction of everything. This means or. So F or A, because D intersect with E is what they have in common. So D in the sets D and E only have A in common. And then we have to write them in order. Okay. So that looks like 14. Definitely you should expect something like this with a different, obviously, flavor. Okay. I do want to ask and make sure that we define finite sets versus infinite sets. So we have question 15 that looks like this. So I want you to identify whether the set is finite or infinite. So let's say the set is A, B, C, D, and then Z. Well, what do we know? Well, the set is finite because the letters of the alphabet is a whole number, which is 26. It's finite, it terminates, that's it. There's nothing more there. So that would be your solution. Okay. So then the next is we want to denote the following set using set builder notation. So set builder notation looks like this. It's the set such that a statement. We have a statement here. That is a set builder. So if I ask you the set of all, so using set builder of the following statement, using X as variable. And the statement is the set of all odd numbers. So the way that you want to write that down as a set builder is very simple. So your solution is X such that X is the set, or X is an odd number. That's it. That's all you have to do. This qualifies for the relation of being an odd number. That's it. Pretty simple. So then the next question, question 17, is the following. I want you to list, this is different. It's not telling you to use set builder. It's asking you to list. So they want you to list out all of the elements. List, that's a different one. List all the elements. Not greater than 8. So if it's not greater, that means less than. That's what this means. So all of the numbers, and they want you to write the whole number, not all, the whole numbers. Whole numbers start with 0, 1, 2, 4, 5, 6, 7, 8. Okay, not greater than 8. So this is what you want to write down. So this would be the whole numbers. If I would ask you for the natural numbers, natural numbers does not contain 0. So 1, 2, 3, 4, 5, 6, 7, 8. Notice the difference. One contains a 0, the other one doesn't. But I asked for whole numbers, so whole numbers does contain 0. All right. Question 18, we're going to use the Cartesian formula. So n of A times n of B is a multiplication of n of A times n of B. That tells you the elements. So if I have n of, Cartesian, so the cardinality of A cross B is equal to n of A times n of B. So this is a Cartesian formula. So note, if I have n of A cross B to be equal to 72 and n of B is equal to 8, and I want to find n of B, sorry, n of A, find n of A, what do you have to do? We'll apply the formula of the Cartesian. So n of A cross P is 72 is equal to N of A times N of B, but you know that N of B is 8. So you're solving an equation again, times 8. So how do I solve for N of A? Well, you divide both sides by 8, and you get 9 is equal to N of A. So you're solving. All you're doing is solving, you're isolating an equation. So again, the cardinality of a following set, all you have to do is count the elements of a set. So let me see, my pencil start working again. And that's it. So this is a very short but concise review. So I highly recommend you some tips for the test. You are allowed to use this video for your test. That will help you. So some tips is writing down the formulas. So the formulas of cardinality, the formulas of Cartesian, write those down. You also want to make sure you note the symbols. So what does this represent? What does this represent? What does this represent? A prime, so complements. What does a complement mean? What does a subtraction mean? All of that good stuff you have to know. A Venn diagram. Things like this you have to know. Definitely how to complete a Venn diagram, what is contained in a diagram, what's not. Okay, so things like that you have to know for this exam. So again, cardinality definitions. This is very brief, so please make sure you look at the review and not only guide yourself to this, but definitely make sure you look at everything that you have available. Look at your notes, your course notes are available for you. So please make sure that you go back and check, and you go and you look. Again, this is a brief example of a practice. I gave you guys additional practice. So if you have any questions, please shoot me an email, but I think that this should be enough. Your exam contains 22 questions total. So I just did a review that contains 18 questions. But your original exam will have 22 questions. All right, so without further ado, that was your first practice midterm for you. Good luck. And if you have any questions, please attend my office hours. Bye, guys.